Imagine this, a clock that ticks forever, a swing that never stops moving, a heartbeat that never dies. Now pause, because what I just said should be impossible. Every machine you've seen breaks. Every motion slows down. Every flame burns out. But quantum physics has found something that refuses to die. A phase of matter that moves in time without consuming energy. A crystal, not of space, but of time itself. Tonight, we dive into one of the strangest, most mind-bending discoveries in modern science, time crystals, and by the end of this journey, I'll leave you with a question that might just change how you see your life, your universe, and your very existence. This is Beyond Newton. Let's start simple. You throw a ball in the air, it goes up, it comes down, and eventually, it stops. You push a swing in a park, it swings for a while, but sooner or later, it slows and stops. Even your heart, beating since before you were born, needs food, oxygen, and energy. Without them, it stops. We live in a world where nothing moves forever, because the rules of physics, the laws we all learned in school, say, motion consumes energy, and once that energy is gone, so is the motion. But what if I told you, somewhere deep in the quantum world, there exists something that refuses to obey that rule, something that moves, changes, oscillates, not for a few minutes, not for hours, not even for years, but forever. No energy input, no loss, an eternal rhythm, built into matter itself. Ladies and gentlemen, welcome to the strange world of time crystals. But to understand what makes them so bizarre, we first need to take a detour into something we already know very well, space crystals. Look around you, crystals are everywhere, a diamond ring, a snowflake, even the salt in your food. What makes them crystals is simple, they repeat their structure in space. Atoms line up in patterns, over and over again. That's why diamonds sparkle. Their atoms are aligned so perfectly that light bends and scatters in dazzling ways. Now imagine this. Instead of repeating in space, matter begins to repeat in time. That means the atoms flip back and forth, endlessly, in a rhythm, like a heartbeat. But here's the shocking part. This rhythm doesn't consume energy. It's like a swing, swinging forever. A pendulum, ticking eternally. Matter itself, beating in time, without ever slowing down. This is what we call a time crystal. Wait, hold up. That sounds like a perpetual motion machine. And didn't science say perpetual motion is impossible? Exactly. That's why when Nobel Prize-winning physicist Frank Wilczek first proposed time crystals in 2012, most scientists thought he was joking. It sounded like trying to cheat the universe. So, how is it even real? Because time crystals don't break the rules. They bend them in ways we never imagined. They don't create energy. They don't violate thermodynamics. Instead, they exist in a delicate quantum balance, a new phase of matter that's simply beyond anything we'd seen before. Every system in nature tends to spread out its energy over time. A hot coffee cools down, a charged phone drains, even stars eventually burn out. This is called entropy, the slow march toward disorder. But time crystals are special. They're what scientists call an out-of-equilibrium phase. Instead of energy spreading out, they lock into a repeating rhythm. Think of it like this. Your coffee cup starts to cool, but instead of going from hot to cold, it oscillates. Hot, cold forever. It's impossible in our daily world, but at the quantum scale, it happens. In 2016, scientists at the University of Maryland built the first time crystal by lining up atoms and using lasers to flip them into a repeating pattern. Then, in 2021, Google's quantum computer, Sycamore, created a time crystal out of qubits, the tiny building blocks of quantum computation. Here's the crazy part. The crystal didn't settle down, it didn't lose its motion. It just kept flipping back and forth. A pendulum, inside the quantum world, that refused to stop. One scientist said, "It's like we discovered a perpetual motion machine, but one that doesn't break physics." That's how revolutionary this is. Still confused? Let me ground this with real-life comparisons. Imagine a drummer tapping a beat. Normally, the drummer gets tired. Their hands slow down, they stop. But in a time crystal, the drum keeps beating forever, even with no drummer. Or think about Earth's rotation. It spins once every 24 hours. Over billions of years, it's slowing. But imagine if it never slowed. If Earth spun forever, perfectly. That's the closest everyday analogy to a time crystal. Matter itself becomes a cosmic heartbeat, eternal, unbroken, untouchable. So why should we care? Quantum computing. Time crystals could make quantum computers stable, resistant to errors that normally ruin calculations. That means breakthroughs in medicine, AI, energy, and more. Energy systems. They could one day inspire new ways to store and transfer energy without loss. Fundamental physics. They challenge our deepest understanding of time. Is time really just a straight line? Or can it form rhythms, cycles, and patterns we've never seen before? And here's where it gets existential. If matter can move forever in time, what about consciousness? What about the universe itself? Some philosophers argue that our cosmos may already be a kind of time crystal repeating in cycles eternally. Birth, death, rebirth, expansion, collapse, expansion again. Think about your own life, your heartbeat, your breath, your daily cycles of waking and sleeping. Are these echoes of a deeper, hidden time crystal that beats at the core of existence? For centuries, humans believed perpetual motion was impossible, that everything must die, decay, and stop. But time crystals whisper a different story. A story where motion never ends, where rhythm is eternal, where time itself can crystallize into something immortal. So I'll leave you with this. If atoms can beat forever like a heart, what does that say about the heartbeat of the universe? And what does it say about us? This is not just physics. This is beyond Newton.